This extraordinary aircraft engine is revered as the biggest insane piston radial ever designed, and it pushes the frontiers of what was formerly considered to be conceivable by virtue of its incredible size, power, and technical expertise. The M-501 is a genuine tribute to human creativity and a sight that leaves aviation aficionados all over the globe in absolute wonder. It was developed by the famous Russian aircraft company Yakovlev. The Yakovlev M-501 is an incredible feat of engineering, but is the size of it an indication of the technological skill that went into creating it? Or is it just an unneeded exaggeration? How was the engine constructed? What materials were used? How big is the engine really? And what can we compare it to? Let's check it out. The Yakovlev M-501 has been able to captivate the imaginations of both aviation enthusiasts and industry experts thanks to the aura of intrigue that has been cast around this unique invention. Its huge piston radial engine, which is unlike anything that has ever been seen before, promises to give an unmatched performance that exceeds the constraints that are traditionally accepted. As we go further into the world of this extraordinary airplane, be ready to be intrigued by its fascinating history, its groundbreaking design, and the astounding technical accomplishments that have resulted in its existence. 1946 was the year when Yakovlev and his colleagues began their first research and development on the M-501. Yakovlev was able to convince the Soviet authorities that the M-501 had more promise than the M-224, which allowed him to achieve his goal of blocking the M-224 from receiving funds. The M-224 project came to an end sometime around the middle of 1948, and its resources were diverted to the construction of the M-501 power plants instead of continuing on with the original design. Massive water-cooled diesel 4-stroke machines, the Yakovlev M-501 engines, were what gave the Yakovlev M-501 series of aircraft its power. The 42-cylinder engine featured an inline radial design, and its 7-cylinder banks were arranged around an aluminum crankcase. The crankcase was the central component of the engine. Aluminum was used in the construction of the engine. There were 7 individual parts that made up the crankcase, and they were fastened together using bolts. These parts included the front, the middle, the back, and any extras that were included. The crankcase included 7 roller-type main bearings in order to sustain all 6 throws of the crankshaft. These bearings were located within the crankcase. Each cylinder bank, which was stud-mounted to the crankcase, consisted of a total of 6 individual cylinders. Aluminum cylinders with steel liners within were crushed using a hydraulic press. The opening and closing of the 2 intake and 2 exhaust valves per cylinder, which were controlled by a single overhead camshaft, was accomplished by the employment of roller rockers. A vertical shaft was located at the rear of each cylinder bank. This shaft spun a set of bevel gears, which in turn powered the camshaft. The crankshaft was responsible for turning all of the other vehicle shafts. Pistons were connected to the crankshaft through 1 master rod and 6 articulating rods for each row of cylinders in the engine. The exhaust was pulled from the left side of each cylinder bank, which required the installation of a manifold at the top of the V that was formed by the cylinder banks. At the very rear of the engine, close to where the exhaust gases were directed, there was a turbo supercharger. The wasted exhaust gases from the turbo supercharger contributed to the generation of 250 kilograms of jet thrust. Another supercharger was located in the gap between the turbo supercharger and the engine, and it was the one that took in the pressured intake air. The crankshaft of the engine was linked to the single speed of the supercharger using a gear system. The air coming from the supercharger was directed via intake manifolds to each bank of cylinders. The intake manifold was positioned in the bottom portion of the V, below the exhaust manifold, and it was coupled to the right side of the cylinder bank. The bore of the M-501 was sized at 160 mm, while the stroke was 170 mm. The engine would have produced 4,750 horsepower if it had not been equipped with a turbo blower, which increased its displacement to 8,760 cubic inches. The power output of the engine was increased by 6,205 horsepower thanks to the turbo supercharger. The weight of the engine was 6,504 pounds when it did not have the turbocharger, but once it was installed, it weighed 7,496 pounds. By 1952, the M-501 had been completed and had achieved more than 6,000 horsepower during testing. In 1953, when it became apparent that jet and turbine engines were a more practical choice for large aircraft than gigantic piston aircraft engines, the project was discontinued. The M-501 was developed for the Tupolev 487 and the Ilyushin IL-26, which both had a total of 4 engines and it was intended to be used for the Tupolev 489, which had a total of 6. These long-range strategic bombers never saw production, hence none of the designs were ever constructed. Development of the M-501 engine did not come to a conclusion since there was no market for it in the aviation industry. The M-501M is the seagoing version of the M-501, which was designed for use on land. The only real difference between the aviation engine and the marine engine was the material used for the crankcase casting. The marine engine used steel, while the airplane engine used aluminum. The M-501M was outfitted with a water-jacketed exhaust system, power takeoff, and a reversing clutch in addition to its standard features. Before we continue, hit that like button and subscribe to this channel for more interesting videos. The history of the M-501M, especially its beginnings, remains unclear to this day. It would seem that Yakovlev was moved to factory number 174 in order to further the design of the marine engine. Factory number 174 in Leningrad, which is now known as St. Petersburg, had its start in 1932 as a division of Bolshakov Plant number 232, which is known today as the Gazobukov plant. Yakovlev departed the factory around the year 1958, despite the fact that factory number 174 had been producing diesel marine engines continuously since 1945. The early versions of the marine engine suffered from a number of issues, which resulted in more frequent instances of malfunction. In the 1960s, when the issues with the engine were eventually resolved, the facility was given the name Zvezda to honor the design of the engine that it manufactured. Radio engines are often characterized as having a star arrangement, and the Russian term for star is zvezda. Radio engines are also occasionally referred to as star arrangements. The M503 marine engine from Zvezda is a redesigned and enhanced version of a type that was available before and had 42 cylinders. The Yakovlev M-501, which has been referred to as the biggest insane piston radial ever designed, is and will continue to be a mysterious marvel that mesmerizes and tests the realms of aviation. Its immense size and innovation design have inspired amazement and astonishment, but at the same time they raise doubts about the actual importance of the thing and how well it'll work in practice. As we set out on a path littered with ambiguities, we came to the realization that the Yakovlev M-501 exemplifies both success and ambiguity at the same time. It's a monument to the never-ending search for technical excellence, which pushes the frontiers of what was previously thought to be feasible. Its bold radio engine encourages us to imagine a world in which there are no limitations placed on creativity. However, hidden within its splendor are issues that have yet to be resolved. A stunning example of technological success or an ambitious experiment looking for validation. The scale of it raises the question of whether or not it's a demonstration of power and strength, or if it is a hint of latent weaknesses that are yet to be disclosed. The Yakovlev M-501 defies simple classification in the realm of aviation due to its unique characteristics. Because of its history, aviation aficionados, engineers, and historians will continue to engage in heated disputes over topics that will continue to fascinate and motivate them. In the end, the Yakovlev M-501's real importance may lay not in its physical manifestation, but in the opportunities it gives for the future of aviation, rather than in the actual manifestation itself. It is possible that this should serve as a reminder that the pursuit of innovation, regardless of how paradoxical or ambiguous it may seem, will always bring us to new vistas and discoveries. As we say our goodbyes to this incredible airplane, let us use this opportunity to acknowledge the sense of awe and celebration it instills inside us, as well as the indomitable spirit of discovery that propels mankind ahead in the sky and beyond. The Yakovlev M-501 will be remembered for all time as a paragon of audacious aspiration and a representation of man's never-ending drive to conquer the skies. But these were our views on it. What do you feel about it? Do let us know in the comments below and subscribe to our channel for upcoming interesting videos.